Hey guys, today we're going to take a look at how to take all the information we've done so far and use it to sketch curves that can look completely ridiculous and we have no idea what they look like. Okay? So the first thing that we are going to do is we're going to go through and look at the function. Okay, so this is before we've taken the derivative, before we've done anything else. We can look at the function, it's going to tell us some different things. Now, there are some sort of more obvious things, well, maybe they're not obvious, whatever. Okay, things like the degree. Okay, the degree is going to give you an idea of what it's going to look like. Now, it may not be a polynomial, so that may not help. But if it is a polynomial, look at the degree, and it's going to give you a basic shape to work with. Okay, regardless of whether it's a polynomial or not, we can take a look, and we can look at the asymptotes. All right, asymptotes. And all of these asymptotes are going to come from the original function. And of course, remember, we're talking about horizontal asymptotes. Horizontal. We're talking about vertical. And we are talking about oblique. Okay? And we can figure all those out using the original function. Okay? Some other things that we can look at is we can find the intercepts. Intercepts. All right, so when we say intercepts, we can find the x-intercept by letting the function, so we'll say by let f of x equals 0, and then solve for x. Okay. Similarly, we can find the y-intercept, and this is one that's often overlooked because it seems kind of obvious. Well, no, I guess it doesn't seem obvious. That's the opposite of the problem anyway. You just sub, it should be obvious. So you're just going to sub in 0 and find out what the y is. Okay? And finally, the last thing that we're going to look for here is we're going to look for end behaviors. Now, we did talk about horizontal asymptotes, so maybe that's going to, well, maybe that's the same thing, but, or sometimes it's the same thing. So behaviors. And remember, to do this, you are going to find the limit of f of x as x approaches infinity. Okay? You can then do it again. This time, let x approach negative infinity. And that should give you the two end behaviors. Well, it will give you end behaviors because that's the definition of end behaviors. So anyway, so those are just some things that we can look at with the original function to sort of get an idea of what it's going to look like. Okay? But of course, this is calculus, so we're going to take the derivative. Once we take the derivative, we can find all of our critical points. All right? Critical points. All right? Not only can we find our critical points, but we are going to be able to identify what type they are. Identify the type. And when I say that, of course, I'm talking about, is it a max, is it a min? You're not necessarily going to care whether it's a global max or a global minimum yet. You'll kind of put everything else together and then you would be able to figure that out. But you are going to want to know, is it a maximum or is it a minimum? Because that's going to help you sort of keep in mind what this should look like. Okay? And we are also going to be able to find the intervals of increase and decrease. Oh, my thing's not working. There we go. Intervals of increase and decrease. All right, so that is our first derivative. But then, of course, we can take the second derivative. And the second derivative is going to give us even more. So from this, we can figure out our points of inflection. And this just allows us to be, sometimes it's obvious that there's going to be a point of inflection because you have a minimum and then you have a maximum. There's no asymptotes between it and it's continuous at that point, or on that interval. There's obviously a point of inflection. But by using the second derivative, you can actually find out exactly where that is. And of course, we can use that information to figure out the concavity, whichever. You can find both. Find the concavity and the concavity. Okay? And there you go. All right. So just a couple things to remember, of course. Nothing profound, perhaps, but remember, you're going to include arrows on the ends when you're going off to infinity or going off to wherever you're going off to. Okay. Don't forget your arrows. actually sketch the asymptotes. Okay, sketch. Oh, my pen's not working. Sketch the asymptotes. And of course we usually use just a dotted line for that. But don't just assume that it's obvious that's what you're doing. Draw them. Okay? And the two big ones, make sure you label everything. Label everything. And finally, do not forget to draw your scale. Alright? The number of times people lose marks for leaving off a scale is incredible. You should never leave off a scale. Alright, and that's it for the lesson. As you can see, we've got some examples here that we're going to try for our warm-up in class tomorrow. Alright, so until next time, go Sabres!